So what are the food additives? So food additives are substances added to the product to perform specific technological function. That means if you want to preserve your food, like food generally you manufactured in the factory or at home, and you have to eat or you have to use this food within few days. But that is not the business. So the commercial function, you have to keep your food for longer time. That means you have to preserve your food. That means you have to increase the shelf life of the food, or in other sense, you have to stop or inhibit the growth of the pathogen or bacteria, fungus, or viruses. And also sometimes adding color and enhancing the flavor for the interest and the variety. So if like the strawberry, your starting color is red, but when you going through the process, you lost the color. So that means you have to keep the red color the entire life of the stability or the shelf life. So that means you have to add some food additives to keep the color. So there are currently 330, not 300, 330 permitted additives, food additives in the Europe, definitely UK, in the Europe also. So flavoring agents are not included. There are hundreds of flavoring agents, but flavor enhancer are food additives, but not the flavoring agents, because they are classified differently. So flavor enhancer, so as I mentioned, that means which make a flavor stronger. Like if you want some particular flavor, you can get by adding some flavor enhancer. So because we don't have that much time also, you can find the full list of food additives in this website, the Food Standard Agency or European Food Safety Agency also. So just a global snapshot. In the Western world, there is a tremendous increase in the consumption of ultra-processed food. Most of the food we are eating every day are processed. So that means you cannot avoid processed food. But there are some food, these are ultra-processed. That means very high level of processing. That means foods undergoing multiple physical, biological, and chemical processes and containing various food additives. 330 authorized compounds, that is in the EU. These are all approved by the European Food Safety Authority by the regulation of EC number 1333/2008. There are 48 food additives. They are allowed in only organic food products. So total 330 authorized food, but out of 330, 48 food additives are allowed in organic food products. There are limits. If you cannot add as many as you want. Like if some food additives are very tasty, that means if you want to add 2 grams, 5 grams, 10 grams, 100 grams, no. There is some regulatory limit. You have to add maximum level. So that means maximum authorized level of food additives are set by the EFSA and the WHO, FAO, JECFA at the international level. So this is the international maximum additive limit. Many companies and most of the cases, you can find there are multiple food additives. If you see any food label at the back, you can see there is a list of food additives, and it is. I am coming to the next slide. So there are some mixed use of food additives. We call the cocktail. So that means if you use single food additives, that effect is 1. But if you use 4, 5, 6, 10 food additives, the reaction is different. So that means you have to be very careful about these cocktail food additives. So processing of food, this your parents always said, don't take processed food, take fresh food, natural food. But it is very, very hard to avoid processed food because most of the food are processed at some level. So food processing plays an essential role in providing edible, safe, and nutritious food to the population and in the food preservation. So that means there are many positive attributes for positive function of the food additives, like make it edible, make it safe, and make it nutritious. And also the food preservation. You can keep food for the longer time. However, the topic is complex with many different types of processes that may bring both risk and benefit. Like, I'm giving you one example. You know this, that pasteurization of milk, because raw milk is a lot of bacteria or pathogen. These are present, and that will create a lot of health problems. And that's why industry are doing the heat treatment to reduce the microbial activity, which may increase the shelf life and reduce the foodborne illness. But at the same time, the thermal processing, that means heat processing, can also have undesirable consequences, such as loss of certain nutrients. You can lose some nutrients, like if you pasteurize the human milk, that also reduces the vitamin C content by 20%. So that means the pasteurization not always good. It is essential because it kills the bacteria or pathogen, but at the same time, it reduces the very important vitamins, that is the vitamin C. Also, sometimes they produce some toxic compound, like the heterocyclic amines and polycyclic aromatic hydrocarbons in the processed meat, or acrylamide as a byproduct of the Maillard reaction. Like we all love barbecue. So barbecue meat is very tasty and very popular also. But if you burn the meat, that means the over heat. So that produce different chemicals like heterocyclic amines and polycyclic aromatic hydrocarbons. So these are all carcinogenic. So that means this chemical can produce a cancer in our body. So that means there are many questions to be resolved. Not all processing are good, but processing definitely we need processing, food processing. We see this E numbers. So E numbers, that means like anthocyanin, that is the pink color, you can see the cabbage, that E163 can be extracted from the red cabbage and used as a food coloring. Like caramel, E150. So what is E? So E is the classification system. The European Union, that is E stand for Europe. That means that if some food additives, it contains E number, E1 to E330, that means these are approved food ingredients. European Food Safety Authority, EFSA, is responsible for regulating the E numbers and making sure they are safe for consumption. E numbers apply to all additives, regardless of whether they are natural source or man-made. So that means we have some idea. So natural are safe, not really. The synthetic products also safe, and natural products also unsafe also. So that means if any product has E numbers, that means these are safe. E numbers are individually approved for use in different foods. This means that E number cannot be used in any food, but only in the list of food that is approved for where it is deemed appropriate and safe. So E numbers means approved food ingredients by European Food Safety Authority. So types of additive. So there are three basic types. One is natural, found naturally, such as you can see the beetroot juice, that is E162, used as a coloring agent. There are another group of food additives. These are synthetic, man-made, identical copies of substances found naturally, such as benzoic acid. So benzoic acid, it can be natural or it can be man-made in the laboratory or the factory. So when it is man-made in the factory, we call synthetic. Like many drugs, many medicine, 90% of the current medicine, these are originally extracted from the natural source. But because anything, if you take one example, Taxol for the cancer. So Taxol coming from the one particular tree, Himalayan yew tree. So to make Taxol, you have to finish the whole world. No tree you cannot find. So that means scientists developed a similar chemical structure that is identical to the natural Taxol. So these are called synthetic, and most of the drug in current world, these are all synthetic, but these are copying of the natural product. Some are artificial, produced synthetically, but not found naturally, like the nisin. So nisin you cannot find in nature. So that means it's a 100% synthetic, and it's made in the laboratory. So there are three types of additives. One class is natural, one class is synthetic, another class is artificial. You can see there is a big list. There are many food additives. The common food additives: acids, bases, that means alkalis, buffer system and salts, chelating agents, that is the sequestrants, antioxidant, very big group of food additives, antimicrobial agents, that is also a very big group of food additives, like the antibiotic we are taking when we are sick. There are two types of sweetener: intensely sweet, non-nutritive and low-calorie sweeteners, and polyols, that is sweeteners, texturize, and emulsifiers. So I will take a separate class on the sweeteners. So it's a very evolving area. So that means you need some good knowledge in this area. There is another big area, the stabilizers and thickeners, like sauce. We are using every day that tomato sauce or barbecue sauce or different types of sauce. So sauce should have thickener, because sauce is not a very solid or not a liquid. It's a semi-liquid or semi-solid. So there is a thickener. stabilizer to keep the shelf life long. Fat replacers. See, people are more concerned about the weight every day, and that's why the consumer want to replace fat into their food. So that means there are many carbohydrate, many protein. These are used in the food as a fat replacing agent. Masticatory substance, forming texturizer, appearance control and clarifying agent, and anti-cacking agent, and gases and propellant. So these are the major list of food additives. But there are many food additives. These are not listed here, but these are the major food additives. If you see this pie chart, so few food additives, these are present currently in use. Some are 33%, some 25%, some 28%, some 20%, and there is a list: acidity regulator, antioxidant, carrier, emulsifier, flavor enhancer, gelling agent, preservative. There are all types of food additives. These are using currently in the global food industry, and you can see the percentage of the use. You can see the classification of the alteration that can occur during the handling, processing, and storage. So some food has 1 week, like the bread, 1 week shelf life. Some food has 1 month shelf life. Some food has 1 year shelf life. Some food has 2 years shelf life. So that means, so when food going through the handling, processing, and storage condition, there is some changes in the food. So major changes are texture changes. So loss of solubility, loss of water holding capacity, the toughening, softening. So these are the texture related. Flavor related, development of rancidity. Some when your yogurt, if you keep outside, it will some foul, bad smell. That means there is some oxidation or hydrolytic effect. So this is called rancidity. Cooked or caramel flavor, other off flavor, or desirable flavor. So these are all flavor related. Color related, it can be a dark color, it can be a bleaching color, or it can be a browning of baked goods. Because like a biscuit to bread, we want some brown color. So that means you have to add something that will give some brown color of bread and a biscuit also. Nutritive value, loss, degradation, altered bioavailability of protein, lipid, vitamins, minerals, and other health promoting contents. As I said, if you heat the human milk, so you will lose 20% of the vitamin C. So that means, so some cases you can gain, some cases you can lose. Safety is one of the most important things. So like if you heat meat at a certain temperature, so there will be some toxic substances, as I mentioned before. So that means during handling, processing, and storage, there are many changes. Texture changes, flavor changes, color changes, nutritive value changes, and also safety. So there are several biochemical, chemical, and biochemical reactions that can happen. What are these? There are 2 types of browning of the food. One is enzymatic browning. So that means some enzyme is involved, and there is another type of browning, non-enzymatic browning, like baked goods, dry, intermediate moisture food. enzymatic browning, cut fruits like apple. I give you example. So if you cut apple and keep it on the air, it will get browning. That is the enzymatic browning. Oxidation, lipid, like if you keep your yogurt outside, it will get oxidation. Hydrolysis, lipid, protein, vitamins, carbohydrate, pigments, they are hydrolyzed. Metal interaction, like the complexation, loss of magnesium from the chlorophyll, like we call chelation. Chelation, that means metal bind with the food. So that means complexation. If some metal that binds with the anthocyanin, so that change the anthocyanin characteristic, the color, everything. Lipid isomerization. So that means we know a cis position and trans position. So from cis to trans isomerization, and also sometimes it is not conjugated, not bind. That is called non-conjugated. It transforms to the conjugated. So that means two food additives or additives with some others, they combine together. Lipid cyclization, monocyclic fatty acid, lipid oxidation, polymerization. So when you deep fry, so deep fry food is not good for health, because when you deep fry, they form some polymerization. That means the fat polymerized. That is bad for health. Protein denatured. So like if you add some enzyme or if you eat, so your protein breaks. Like enzyme is a protein, hormone is a protein. So that means called protein denaturation. Protein cross-linking. So that means one protein that breaks and they bind with the other protein. Polysaccharide synthesis and degradation, and also the glycolytic changes. So there are many chemical and biochemical changes that happens when you process your food. Now I will touch base few important food additives. The first one is the acid. It is a big food additives in food industry. There are two types of acid. First class is organic acid, and second class is inorganic acid. Acetic, adipic, benzoic, citric, formic, fumatic, lactic, malic. So these are under organic acid. Phosphoric acid and some organic and inorganic acid function arranging from inside. Acids are added to the numerous purposes in food and food processing, where they provide the benefit of many of the natural actions. So we are adding acid in the processing system, food processing system, mainly for buffering system, and also some to stop some metabolites formation also. Bases, alkaline substance are used in variety of application in the food and food processing. Buffering and pH adjustment, like if you make some fruit juice, so that means fruit juice is normally it is a very, very low alkaline or low acidic sometimes. So you cannot drink. So you need something close to the 7, that is the isotonic. So that means you have to add either acid or alkaline to make it we call the pH adjustment and buffering. Carbon dioxide evolution during baking. Enhancement of the color and flavor also, and solubilization of the protein and chemical peeling. So ripe olive are treated with the solution of sodium hydroxide to aid in the removal of the bitter principle. So olive is bitter, but when you make different food grade product from olive, you don't need a bitter taste. Like olive oil to olive jam or olive, so many different types of food products. So that means the ripe olive, if you treat with the sodium hydroxide, that is sodium hydroxide is a alkali of the ripe olive. Pretzel, this is one of the very popular foods also, snacks, are dipped in a solution of 1.2% sodium hydroxide at particular temperature before baking to alter the protein and starch so that the surface becomes very smooth. If you remember the pretzels is very smooth and shiny. So that you can get only if you use some 1.2% sodium hydroxide. Strong bases, sodium hydroxide about 3%, are employed for the peeling of various fruits and vegetables. So peeling sometimes very difficult. You cannot peel. So, but if you dip your fruits and vegetable like 3% sodium hydroxide, you can easily peel this one. So there are a lot of advantages when we use alkali or bases in our processing system. So acid, bases and buffers that control the acidity or alkalinity of the food for safety and stability of the flavor. Next one is antioxidant. I already described a little bit. Antioxidant, that means it prevents oxidation in our system. So oxidation, what is oxidation means? So oxidation occurs when electrons are removed from an atom or a group of atoms. So oxidation reaction may or may not involve addition of oxygen or removal of hydrogen. So oxidation is very bad in food. So that means that there are many effects, bad effects from oxidation. So it spoil your food. It develops some very bad taste or flavor of the food also. So off flavor we call. So ascorbic acid, phenolic antioxidant, citric acid or EDTA as a chelating agent, tocopherols. There are few synthetic antioxidants like butylated hydroxynisol, BHA, BHT, and TBHQ also. These are all synthetic phenolic antioxidants. So these are heavily used in food industry. So what is the purpose of antioxidant used in food industry? Prevent food containing fat or oil from going rancid due to the oxidation. That is unpleasant odor or flavor. Prevent the browning of cut fruits, vegetables and fruit juices. So if you once you open fruit juice and keep it outside, so within an hour it will get rancid. Some tart bit, off flavor, a color change also. So the most common is the vitamin C, ascorbic acid, E300 is one of the most widely used antioxidant in food industry. There are huge antimicrobial agents. These are used as a food additives in the food industry. I am not going in detail because it's a very big one, but I can only mention few things. Sulfides and sulfur dioxide, nitrite and nitrate salts, acetic acid, propionic acid, sorbic acid, lauric arginate, nitomycin, benzoic acid, epoxidized, and wide range of antibiotics. So these are all used in the food industry as a food additives. So antibiotic we are taking as a medicine. These are separate things. But there are many antibiotics, they are also used in the food. So that means especially in the animal feed, there are huge number of antibiotics. They are used in the animal feed. And the diethyl pyrocarbonate also. Sweetener, it's a big industry. It's a multi-billion-dollar industry. if you see the chemical structure of two sweet things, the top one is the glucose one. This is the very common sweet product, and the bottom one is the aspartame. This is the artificial sweetener. It is not a glucose, but you can see the completely different structure. So sweeteners are two types of sweetener. One is intense sweetener. We called some example are acesulfame K, very common. Aspartame, very common. And stevia, it is a natural sweetener. It is not artificial sweetener. Have a sweetness many times that of the sugar. Sometimes it is 30 times a sweetener, sometimes 100 times, sometimes few thousand times sweeter than this sucrose also. So that means we called intense sweetener. And therefore, because when you use stevia at home also, you have to use very small amount, because it is 160 times or 200 times sweeter than the sucrose also. And there is another category of sweeteners that is called bulk sweeteners. That is sorbitol is a good example. Have similar sweetness, like it has no intense sweetness, like not 200 times or 400 times, 1000 times sweetener. It is very close sweetness of the sucrose, but used at the same level. Like sorbitol is used in the sugar-free chewing gums and sweets also. Most of the sweets you can find that use sorbitol. So sorbitol is a bulk sweetener. This very interesting, very informative. You can see if you consider sucrose as a one sweetness, like if you go to any restaurant and if you love hot food, you can see the 1 chili, 2 chili, 3 chili, 4 chili. So that is the picture of chili. That means 1 chili is very mild, hot, but 4 or 5 chili is very hot. So that means sucrose is the one, that is a unit, and you compare with the other. So acesulfame K, 200 times sweeter than sucrose. Additives, 2000 times sweeter. Aspartame, 180 to 200 times. Cyclamate, 30 times. Monilin, 3000 times. Neotame, 7000 to 13,000 times. Saccharin, it's stopped now. Stevia, stevosides, 300 times. Sucralose, 600 to 800 times. And thaumatin, I just mentioned, it is a very, very latest modern sweetener. It is made from one African plant that is 1600 to 2000 times sweeter than the sucrose. So fat replacer, it's a huge market. So people, the health conscious people, they don't like the bad fat. Not all fat are bad, as you know. So there are few fats. These are bad. That is, but there are few fats. These are good for health also. So here we are talking about bad fats. That is the LDL. So low density how can you replace fat? You can use carbohydrate fat mimetics. So that means you can use some carbohydrate that replace fat. So that means fat mimetics. You can use some protein that replace fat. So reduced calorie synthetic triglycerol fat. You can use some synthetic molecule like reduced calorie. That is triacylglycerol. That also substitute fat. Synthetic fat replacer, that is a polydextrose, sucrose, polyester. So this is widely used in food industry. That can also replace fat. So just few more information about the fat replacer. The carbohydrate fat mimetics. So these are the most dominant fat replacer in the market, like the processed starches, gums, hemicellulose, cellulose. These substances mimic the smoothness and creaminess of the fat in food, primarily by moisture retention and bulkiness of their solid that assist in providing the fat-like sensation. Like ice cream. If ice cream is like a yogurt or some other type of things, like a coffee, you can't eat ice cream, because ice cream, you need a smoothness and creaminess, and that is coming from the fat. But you can replace fat in ice cream by some carbohydrate fat mimetics, like a different type of starch, gums, hemicellulose. So that means you can still keep smoothness, you can still keep creaminess, but no fat there, or minimum fat also. Protein fat mimetics, there are very few protein fat mimetics, or most of the fat mimetics either carbohydrate or synthetic, but there are few protein fat mimetics, particulate protein that obtained from the soluble protein by different methods, the hydrophobic interaction, isoelectric precipitation, heat denaturation. So that sort of interaction, you can get some particulate protein, and you can use in to replace the fat also. There are many synthetic fat replacers like the polydextrose, sucrose, polyester, and owing to their synthetic nature, these compounds are resistant to the enzymatic hydrolysis and largely undigested. That means if you are taking this synthetic fat replacer, but it is not digested in your GI system, in your gut. So that means it passing through the stool. So this is very healthy, because we have always feared about the synthetic molecule, but if it is enter into our body, so that can damage our body. But if it is not break or undigested, it will pass through the stool also. There are, I think there is no processed food without preservative. There is no processed food. All processed food have some preservative, but these all preservatives should be approved and at a certain concentration also. So what is the purpose of preservative? Prevent the growth of microorganisms which could cause food spoilage and lead to the food poisoning. Extend the shelf life of the product. That means if you control the virus, bacteria, or some other pathogen in your food, that means you can extend the shelf life of the product. So that means they can distributed and sold to the consumer with a longer shelf life, like bacon, ham, corned beef, other cured meat. We are buying from supermarket every day. These are always with nitrite or nitrate. That is E249, E252, that range. So nitrate range. So that curing the process, and that also prevents the spoilage of the meat. Color is very important in food additives, because you need color of the food. So if your food is dull color, nobody will attract it. So that means you need a very bright color. Like, you know, this I every day I am seeing one advertisement from Fanta. That is a drinks. Fanta now in the market with so many different colors. So that means people drink Fanta due to the different exciting color. So that means you need color. Restored color lost during processing or storage. That means that matter of fact, peas, when you go through the processing and if you store for few months, you will lose the original color of the narrow fat peas. So that means you have to add some color to keep the original color, restore the original color. Ensure that each batch produced is identical in appearance and does not appear off. That means if you buy one food today, like one yogurt from the supermarket, and next week you are buying the same yogurt with a slightly different color. So that means you have to keep the manufacturer, food manufacturer, they have to keep the color consistent, same color every batch. So that means you need a very consistent use of coloring agent. Reinforced color already in the food, that means enhance the yellowness of the custard. So if custard is not yellow, nobody will eat. So you have to enhance the yellow color of the custard. Give color to the food which otherwise would be colorless, like soft drinks. Because when like Coke or Pepsi, they manufacture soft drinks, initially soft drinks are colorless, no color. They add some color, but this color should be approved. That means it has go through the toxicological study, so it has no bad effect on consumers. So like color and hyperactivity, especially children also, certain combination of artificial food color have linked to the negative effect on children's behavior. We all know. So these are not banned color, but you know that when you buy like lollies, if lollies are coming with some color, they have to mention may have some adverse effect on activity and attention in the children, like sunset yellow E110, alura red E129, quinoline yellow, tetrazine, carmoisin, and ponsio. So these are the 6 very common coloring agents. These are used in children's food like soft drinks, sweets, ice cream, lollies. So that means, so the packaging must have some declaration, some wording, may have an adverse effect on the activity and attention in the children. Flavor enhancer. Don't mix flavoring agent and flavor enhancer. Flavoring agent are not part of the food additives. Flavor enhancer are the part of food additives. So flavor enhancer bring out the flavor in the food without imparting a flavor of their own. As I mentioned before, the monosodium glutamate, this is one of the very common flavor enhancer. Their E number is 621. Enhances umami flavor. You know that Japanese food, people love that flavor, umami flavors, and you are not getting that flavor normally. So you have to add something to get that flavor. So that is the flavor enhancer. So flavoring on the other hand are added to a wide range of food, but these are not part of the food additives and no E number because they are not food additives. All food additives, approved food additives, should have E numbers. So there are a few other food additives, that is anti-caking agent, like salt or sugar or dry milk. You need a free flow. So if your salt is clogging or sticking each other, not good. If your powdered milk sticking each other, nobody will use. You need a free flow. So that means you need a anti-caking agent to ensure the free movement of the free flow of the particle. That is called anti-caking agent. Anti-foaming agent, like fruit juice. When you pour the fruit juice, and if there is a froth, like the beer, when you add beer, there is a huge frothing. But fruit juice, you don't want froth. So that's why you have to add some food additives that stop anti-foaming agent also. Glazing agent like confectionery lolly, that should be a very glazed, shining glazed, that protective coating or sheen. So there are many glazing agent, approved glazing agent. These are used in the confectionery industry for good appearance, the shining appearance, and also increase the shelf life. This is one of the largest class in food additives, that is called emulsifier, stabilizer, gelling agent, and thickeners. So almost every processed food that has these food additives. So emulsifiers help mix ingredients together that would normally separate. Example is lecithin E322. As I mentioned before, oil and water you cannot mix together. So you need some emulsifier that can mix or that can hold the oil and water. Stabilizer prevent ingredients from separating again. One example is the locust bean gum E410. So that means first is emulsification, second step is stabilization. So that means when you use lecithin, it can bind oil and water, but they can separate out also. So that means you need some stabilizer so you can keep this bonding for long time. So emulsifiers and stabilizers give good consistent texture. They can be found in the low-fat spread. Like we are every day using the spread, low-fat spread. So there are a few fats and some non-fats thing also. So that means you are getting a consistent structure because emulsifiers and stabilizers are present there. Gelling agent are used to change the consistency of a food, like a pectin E440, like a jam. So jam is a some level of consistency. Like jam can not like a spread, but jam is slightly thicker, but still you can spread on the bread. So that means some gelling agent you need to make jam, and pectin is one of the good example of food additives. Thickeners like the sauce, as I mentioned before, thickeners help give food body and can be found in the most sauces also. Is now the most important part: safety and suitability of food additives. Unless your food additives are safe, you cannot use, because these food additives through the food that goes in human bodies. That means at the recommended level, if it is 10 milligram per kilo, so that should be safe for human consumption. So safety. Food additives are thoroughly studied, including extensive toxicological testing before they are approved for use in food. You know, anything, any food ingredients, any food additives, any herbal product, any natural product, when it is going to the human body, that has to be tested for toxicity and safety studies. And what are the toxicity studies? These are all safe for everything, like the medicine also. So all medicine that pass through the toxicity study. So toxicity study has different level. One is the short term, that is called acute test, 7 days, 14 days studies on the 2 animals. One is the rodent and another is the mammal. So you have to test your product on 2 animals for short term, that is called acute toxicological test, and the long term, that is called chronic toxicological test. That is 3 months, 6 months, 1 year, 18 months up to. So you have to test there is no toxicity. You have to test carcinogenicity. That means that your product, your food ingredients or food additive has no cancer producing activity. That is called carcinogenicity. So when you have done all these studies, then European Food Safety Authority or TGA in Australia or US FDA in North America, they will approve your ingredients or additives. So that means they are safe for use. US FDA guidance for industry and other stakeholders, toxicological principle for the safety assessment of food ingredients, they call Red Book. You can get all the regulatory guidelines for food additives. Food additives identity, purity, and quality is provided through adherence to the specification, which are developed prior to you. That means these are all same. Food additives, food ingredients, like functional food, nutraceutical, these are all same. So first is the chemistry, then is the quality, then is the toxicity, then the efficacy. That means you should know that chemistry. So is it a fat, carbohydrate, or what type of chemical reaction happens? Then you have to the purity and quality. That means it is not adulterated. There is no mix of things. Then you have to prove the efficacy. So it has no bad effect. It has good effect on the human. Then you can go into the market. So that means to bring a new molecule, new ingredient to the market is not easy. So you have to go through so many steps. And if all are good, then you can go to the market. So that means food additives have been used safely for decades.